Hi everybody, welcome back. So today I'm going to do the video on how to solve for the forces in a member, in all the members in a truss using method of joints. This is one of the topics that is very hard to explain. I really hope you understand my handwriting, so let's get started.
So this is what I'm going to go through right now. Then we are going to solve it step by step. Then I have another example that we will go through. First of all, I drew this truss. Now this truss has equilateral triangles because every angle is 60 degrees and every bar is going to be 2 meters. We have here 7 pins, 11 bars, and 3 reactions. Therefore, the degrees of freedom left is 0. Therefore, it's statically determinant, which is great. Now, we have here a fixed pin. Because it's a fixed pin, we have 2 reaction forces that will be acting on it horizontally and vertically. Then we have here a roller pin, which will only have a vertical reaction force. We also have 2 loads. We have 100 kilonewtons from the G pin. And then we also have a 50 kilonewtons load on the F pin, okay? Now, we start on the whole truss, okay? We start there, the full truss. Then we use the equilibrium equations, the 3 equations. The sum of forces horizontally should be 0. Sum of forces vertically should be 0, and the sum of the moments should be 0. Let's take the clockwise moment to be negative. Okay, first of all, let's look at the horizontal forces. Now, the only horizontal force we have here in this truss is actually AH, which is the horizontal reaction force on the A pin, okay? There is no other forces that go horizontally. So what that means, that means AH, okay, must be 0, as you see there. Now let's take the vertical forces, the sum of the vertical forces. So here, the reaction force on the pin AV, we're taking upwards direction as positive, plus EV from the roller pin here. Then we get, these are going downwards, so then we do minus 100 and minus 50, you get 0. Therefore, we got an equation here. AV plus EV equals 150. However, there is a problem. We have 2 unknowns, and this can, like, we can't find both unknowns. It could be any 2 numbers, but we always take moments. Now, I picked the pin A to take moments about. And the reason I picked A to take moments about, because that way it cancels out 2 forces, AH and AV. So that makes our life much easier, as you see there. Now, if we take moments about A, you get this force 100, okay? It's 2 meters away because all bars are 2 meters. So 100 minus 2, and we're taking clockwise as negative. So that will be minus 200. And then we get the other force, 50. That is 50 times, because 2 bars, that's 4. Distance is 4 meters. 50 times 4, that is 200. So minus 200 minus 200, that's minus 400. And then you get the EV, that's 6 meters away. So that's plus 6 EV. When we rearrange it, we get 6 EV equal 400. And then we know what EV is, 66.7 kilonewtons, which is great. Then we can find for AV. Now that we know all the unknowns, then AV will be 83.3 kilonewtons. That's great. Now we looked at the truss as a whole. What I would usually do then, draw a table of each joint. So you got A, B, C, D, E, F, G. Put the joints, the known forces. Now, so the known forces for A, we know 2 forces, the AH and AV now, but there's also forces going through the bars to point B and to point G. So we've got, and we don't know these forces. We need to find them out, okay? So we have 2 known forces and 2 unknown forces. And then for B there is 3 bars and no other reaction forces. We don't know any other forces. So 3 unknowns and 0 known. And then I complete the table in that manner. Then, second thing I would do is choose a joint. So I will choose a joint, but the joint must be 2 or fewer unknowns, because that way, again, makes our life easier and it actually works. We have two joints with 2 or less unknowns, A, and we also have E. These are the only ones. We could either pick A or E. And another thing, we are going to assume all of the members are at tension. So if we get a negative force, then that will be compression, because compression is opposite to tension. We then redraw the truss in this way. We remove the pins and we draw the tension forces that go in this way. You see how the arrows work, okay? And with the reaction forces and everything. So now we know which forces we need to find out, okay? We have to find all the arrows that are forces. We have to find them out. Right, next step is you isolate the joint that you picked to start with. We started with A because it only has 2 unknowns, and you will see why picking that joint is really good. So then we draw the forces that's on that joint. 83.3 kilonewtons, we found that already previously. We put it here. Then we got FAB, which is the force between joint A and joint B. And then FAG, that's for joint G. What the cool thing is that if we find FAG, then we have 1 less unknown for joint G. Same thing with FAB, then joint B, we have 1 less unknown. Right, we use the equilibrium equations again. Let's take the vertical, right? The vertical forces to be 0, right? The sum of the vertical forces are 0. The upwards force is going to be positive. So now we have 83.3, as you see here, and then plus the after we resolve the force, the diagonal force here, FAB. So that will be 83.3 plus FAB sine 60, then that should be 0. And if we calculate, okay, FAB must be minus 92.2 kilonewtons. And because, as we said earlier, if you have a negative sign, then it's a compression. That's cool. Now, we look at the horizontal forces. So the horizontal forces here, we will need to trig for FAB again. We don't know what FAG is, and that's what we're trying to find. So because it's going to the right, it's positive. FAG plus FAB cos 60, by resolving this force to the horizontal, must be equal to 0. And the way we do that is because we already know what FAB is now. So we replace the FAB with this, and we use the calculator again. FAG must be 48.1 kilonewtons. So that is tension. Now, what we do next is we move on to the next joint. Which joint we are going to pick? Is it B or G? Now, we will look at it. We have now 2 unknowns. After finding FAB, we have 2 unknowns for joint B. For joint G, we used to have 4 unknowns. Now we have 3. So obviously, we're going to pick joint B next. All right, so after we finish joint A, and then we know that we have to go to joint B, then we will isolate that joint by itself and draw the arrows for the forces. Now, for the people who wouldn't know which direction you need to go, even though if it says tension, so the tension is actually on the joint. So when it's tension, that means the arrow should go outwards. Not if it goes inwards, that means it's compressed. So think about it joint by joint, not the full picture. Then you again use your equilibrium equations for the vertical and the horizontal sum of forces. So here we did the sum of forces in the vertical forces, where we have to end up using trigonometry again. As we already know that the angle is 60 degrees, then we'll have to do, and we already know some of these forces. So then we will do 96.2 sine 60 because of that force that we found from the previous joint A. Then we do minus FBG sine 60. The reason it's negative is because this is diagonally going downwards, equals 0. And then we can use algebra to find for that one. Now this then applies to everything else. Then we go G. Now you'll ask why we went to joint G. Because joint C, we didn't have enough known forces. We didn't have at least two known forces. But G, we had two known forces. So yeah, so then we go to joint G. After we find the forces on there, then it will be easy for us to go to joint C. We will do the same thing. And then the coolest part is when you get to the second last joint, then like here, we went from joint A to joint B to joint G, then C, then F, then E. But did you realize we didn't have to do joint D? Is because when we finished joint D, we found all the unknowns. Because so that's cool. That means every time, all you have to do is to find the unknowns of the joints, and then the last one you wouldn't need to analyze it. There is another example here that I made. This is a bridge. Okay, so it's a truss of a bridge, and it's supposed to be between this and this. Then we have a roller pin here, fixed pin here, so we'll have some reaction forces here and there. We have the joints, the bars. We know the angle is 20 degrees here. So the length of these, as you see, is 10 meters, 10 meters, 10 meters. And you have some forces, some loads applied there, which we also have to take into account. So we look at the full truss again, just like the previous one. We use our three equilibrium equations. Sum of fx should equal to 0. So the only horizontal force we have AH, which is the support here. And so therefore it must be 0. Then we look at the verticals and we sum them up and they should be 0, but we end up with an equation which we have two unknown variables. So we'll have to then go to moments. Pick one of the joints where you want to take moment from, and always take the one where you could eliminate most of the forces because their line of action goes through that point. So we will take joint A, and then using that, here is the equation. You could pause and see how it works. You could try it yourself, in a matter of fact. And then we find all the unknown forces for the supports. Let's start with A, because that's the one where we have at least two knowns. So here we isolate it again. We draw the arrows to represent the forces. We know the angle, 20 degrees. So the 66.67, we got it from the reaction force on the support. So you have to include that. That's very important. And then that's FAB. That's the force that's supposed to go through that bar. And that's FAC through this bar. Okay. Then you use trig to resolve the forces on each force, as you see, to get the horizontal equilibrium equation and then the vertical equilibrium equation. You have to end up finding both of these forces. Then again, you go to the next joint, and it should be always the most efficient one And here we would pick C because C has only two unknowns, but B has more than two unknowns. So let's go with C. Now with C, then we have found out what FAC is, which is from here, 194.93. And then we include it here. And then we need to find FBC and FCE. Then we again use these equilibrium equations. Then from joint B, after we finish joint B, you could go to joint D. And I think that's better because you get more, you get less resolving forces to do. So that's how it's going to look like. It's beautiful, it's nice, you don't need to resolve much forces. And you just get to the answer using, again, the equilibrium equations. When we get to joint F, now here we have to be careful. We have to include the support reaction as well. And the beautiful thing about this, again, is that when you finish A, B, C, D, and F, you don't need to do E because you found all the unknowns. Now, so that's all. You could try solving these trusses by yourself. I really hope this helped.
It's hard to find all the forces in in a truss, all the members of a truss, even with using method of joints. However, it's all about using your previous knowledge in statics, step by step. So first of all, you look at the truss, what we know a truss is, and then you analyze a truss, all the forces around it, remembering the support, the loads, and using the three equilibrium equations, the vertical forces, the horizontal forces, and then the moments. And then the cool thing about this then is when you finish it, you pick a joint to start from, okay, and isolate that joint, as you know. And then on that joint, think of it just as the simplest thing you could get. You know, things like, remember the first thing you learn in statics, one of the first things is when you resolve forces and find the resultant force. That's exactly what you're doing. We want to find the missing forces on that isolated joint, and then you go to the next joint that is the easiest to find the other missing forces until you finish to the end. So thank you so much for watching this video. I really hope this helped you, and I'm really sorry if my handwriting is not the best, but yeah, have a very lovely day and good luck.